Hi guys, today I have a interesting method to solving quadratic Diophantine equations using the completing the square method. This is something that I came across a while back uh, by myself actually, and I talked to a few of my friends, and they were like, I should totally make a video out of this. So here we go. So today I have a equation. Hold on. I have the equation, which is second here y y squared minus 2xy plus 1 equals 0. So I'm just going to zoom in here a little bit, and this would be the equation we're going to evaluate using the completing the square method, where y is not equal to x, and both x and y. X or y can be elements hold on, of the real or complex plane. I believe that is how you do it. Great. So here we go. So the first step, if for those who are familiar with the completing square method, the first step is to take half of the middle part and square it, and add it and subtract it to both sections of the equation. So let's just do that here. So y plus minus x squared, which is just going to be here. Then we subtract it from this side here, like this, and we set it equal to 0. And then we sort of factor this out into its parts. So we do this minus x squared. You can easily just see how this goes. This actually represents this part here. If you just apply the a squared plus 2ab plus b squared uh, um, expression or identity. Yeah, so uh, that's how that is factored out. Like that. Hold on, let me just cross these out. This is equal to 0. And then we have y minus x. Sorry about the lag. There's a slight delay here. Squared, which is equal to, and you want to get this section and move it over. Gonna get this section, and we want to move it over to this other side. And so we have minus 1 plus minus x squared. So another thing that we want to look at is just this minus x squared here. And the minus x squared will actually just the minus x squared will just translate and transform into just x squared, because a negative times a negative is a positive. And so we have minus 1 plus x squared, which here we can just see that it'll just be a difference of 2 squares. And for the sake of me being lazy, I am going to just square root both sides here, like here, and then we're going to have y minus x is equal to the square root of x squared minus 1, and then add to both sides. And what we have is that y is equal to the square root of the difference of squared here, which is equal to x squared minus 1 plus x. So we figured out what y is, and because we can do that, and we figured it out in terms of x, we can just plug this y back into the equation and solve for x. And so let's move down here. We know the original equation was y squared minus 2xy plus 1, which equals 0. So everywhere there's y, just plug in the identity of what y is in terms of x. And you have, what do you have here? So you have x squared minus 1 plus x squared minus 2x y, just 2x y, which we know y is this, plus x plus 1. So what we are going to do is expand this and then distribute this. So we can expand this out, and what you get is x squared minus 1 um, plus 2x square root of x squared minus 1 uh, plus x squared. That's what we get. And then on this side, we just have 2x uh, minus 2x squared minus 1 plus, no, actually, it would just be minus 2x squared plus 1. And you can see here that things just cancel out. Um, and that also just implies that x equals 0. But let's just cancel it out so we can see the process. So you cross out the ones, you cross out these terms here, and x squared plus x squared is just 2x squared minus 2x squared, which we know just equals 0. And at this point, it's pretty obvious that x has to equal 0 for this to check out and be equivalent, not equivalent, equal to each other. And since that is the case, and you could also just prove this by taking out x over here, or you just not even taking out x, just taking out x squared. Then we have 2 minus 2, which equals 0, and 2 minus 2, you can divide that by that side, which is just 0 divided by 0, which you get 0. And x squared would just be equal to 0. And you could just do that, and there you go. So you can even prove it with this. But this makes sense for it to be 0. So x would have to be equal to 0 for it to check out. So let's move down here. So we know that x equals 0 now, and we also know what y is in terms of x. So you just plug in the solution of x into y. And so we know that y is equal to x squared, which is just 0, minus 1 plus x, which we know x is 0. And here we have our solution. Y is equal to the square root of minus 1, which that is just I. And then we know x is equal to 0. So we know that y equals I and x equals 0. So we know at which point this Diophantine equation is equal to 0. So we can check our work by just plugging this in. Here we can plug this in. Let's see. So we have I squared minus 2x, which x is equal to 0, times I plus 1, which equals 0. This cancels out, and what you're remaining with, well, I squared is just minus 1, and then you just remained with minus 1 plus 1, which is just 0, and this equals a 0. And we have finished. And this is how you solve a Diophantine equation using the completing the square method. You can play around with this, with different setups of the equation. For example, you can have y squared minus 5x squared of y plus 1, and you can play around to see how that works. We can have x squared minus y uh, plus 1 as well. Or it doesn't have to be plus 1, it could be any number. Uh, yep. Thank you guys for giving me your attention. Adios.